we're going to do something called the Power Series. Sounds kind of neat. And normally we would start at 1 because it's just convenient for the first term, second term, third term. But we want to get x to the n to be 1 plus x squared plus x cubed, blah, 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 blah. And x to the what is 1? Yeah, that's why this is the only time we start at 0. Most of the time we start at 1. We're just going to do it this way because we're going to generate this equation. Now this has a shape to it when you add a bunch of terms, but I need your help. I need you to take out your calculator. To put in the power rule, what you're going to do is you're going to clear this. I'm going to clear this, and I'm going to make sure I'm in the right mode. I'm in the function mode. Were we in sequence mode before? Okay, so go back to function mode, and you're going to do 1 plus x. That's a good one to start with. And then 1 plus x squared this time. And then we're going to do 1 plus x squared plus x cubed. Okay. And then I'm going to do one more, 1 plus x squared plus x cubed plus x fourth plus x to the fifth plus x to the, x to the sixth. Go to 8 plus x to the 7th plus x to the 8th. That's a lot. And then when we do the window, we're going to look at the window between -1 and 1. And then we're going to go from -1 to 4. A lot of button pushing. And when you see those, you get this wonderful error. What did I do wrong? Bet I did something in the window. -1 to 1. I see. That's okay. -1 to 4. Now we're good. So here's y equal x plus 1. Here's 1 plus x squared. Looks a little different. Here's 1 plus x squared plus x cubed. Look at how it's really hugging the center part really well. Here's the one with x. I think this is the one that went to x to the 8th. See how slow it is? But look at how close it is in this part. If you took the limit as x goes to infinity, this is going to fit an interesting shape and go below here, y equals, and I'm going to take out all of these except the last one. Don't take out the last one, all that work you did. Go 1 divided by 1 minus x. There's no way that's what it's the same as. Well, look at this. There's that. And then look at this. This blue line is 1 over 1 minus x. And look at this 1 plus x squared, x cubed, all the way to x to the 8th. Look at that. It's perfect. Perfect fit. Except on the ends. So you need to add more terms to get the ends to fit a little better. But this is the match for the power series. So what this means is that every time you see this sum as n goes from 0 to infinity of x squared, you can replace it with, I'm not kidding you, 1 over 1 minus x. This is a big deal because this is starting to make series very important to things like integrals. Where we couldn't do certain integrals, we're going to be able to do those now. And let me kind of show you what this means. So we are going to take 1 over 5 minus x, and I'm going to pull out a 5. So this will be 1 minus x over 5. Do you agree that these are the same? Yeah. Now remember here that this is the same as 1 over 1 minus x. 1 over 1 minus x. So I have this looking very much like this, but what's different? What's different between the x is now x over 5, but I still have the minus intact, the 1 intact. There still is this little 5 difference here too. So I can rewrite this sum as n goes from 0 to infinity. I can still keep that 5 out here. I can still keep the 5. And instead of x, which I have here, I'm going to replace it with x over 5 to the n. So what we did is we transferred a formula into a series. And I'm going to play around with this just a little bit algebraically. I'm going to say that this is 5 times x to the n over 5 to the n. Do you agree with that? And then this is the same as 5 to the n over 5, right? Or I would just say 5 to the n minus 1. This and this work to be the same. Huh? Pretty good. Let's try this guy. X squared, and this is the last one we'll do. X squared over 8 plus x. So remember, sum as n goes from 0 to infinity of x to the n is the power series, can be replaced with 1 over 1 minus x. I'm going to pull out an x squared. And I'm going to pull out an 8. You know what I did? I didn't have the algebra wrong on that last one. I pulled out a 5. It should have been a 1/5. Ugh. Rats. Okay, so anyway, 1 over 1 minus a negative x over... Yeah, let's try this. Let's make it a little bit bigger here. X squared, and then this is going to be 8 times 1 minus a negative x over 8. Now, does that look okay? Are these the same? They're the same, aren't they? So then what I'm going to do to make this series is I'm going to go the sum, n equals 0 to infinity, 1x squared over 8. That's pulled out in front. And then this is going to be replaced with negative x over 8 to the n, because this is x to the n. And then this is going to be the sum n equals 0 to infinity, negative 1 to the n. I'm just going to take this negative 1 to the n. I have x to the n plus 2 over 8 to the n times 8, which will be plus 1. This dude is the same as that.